This video is sponsored by codingskill.net. Please visit our sponsor. The Fibonacci sequence is a series of numbers. The next number is found by adding the two numbers before it. We want to generate Fibonacci sequence up to a given number n, where n can be any positive number. For example, the sequence above is for n equals 10. The output for input 0 is 0. For 1 it is 1. For 2 it is 1. For 3 it is 2. For 4 it is 3. The first two cases are base cases. The recursive case can be expressed by the recurrence relation. We can generate this sequence using recursion. We have two base cases and two recursive cases. Let's look at the recursive calls made for n equals 5. We make two calls for 5 minus 1 and 5 minus 2. F of 4 makes two calls, f of 3 and f of 2. F of 3 makes two more calls. We reach the base cases. F of 3 makes two calls. You can see redundant calculations. A binary tree with 4 levels looks like this. Level 0 has 1 node. Level 1 has 2 nodes. Level 2 has 4 nodes. Level 3 has 8 nodes. We can express the number of nodes in terms of powers of 2. For a binary tree with height n, total number of nodes is equal to 2 to the power n, where n is the number of levels. Binary recursion runtime is equal to O of 2 to the power n. This is exponential in time. Let's look at how we can improve the performance. We can avoid computing the value more than once by caching the value for n. If it is in cache, we return it. Otherwise, we compute and save the value in the cache, then return the computed value. This is an example of dynamic programming. To improve performance using dynamic programming, the problem must have overlapping subproblems. Fibonacci sequence is an example of a problem that has overlapping subproblems. Time complexity is O of n. Lookup time for cache is constant time. The space complexity is O of n. We can write an iterative version of the Fibonacci. The edge cases are handled for when n equals 0 or 1. We build a series bottom up. We keep track of the previous two numbers at each step. We initialize variables before previous, and current before we enter the loop. We then update the current value by adding the two previous numbers. And then we update the before previous to previous as we shift moving towards the right of the sequence. And the previous becomes current. And we keep iterating until we reach nth Fibonacci. So f of 0 is the before previous, and then we have f of 1 as the previous, and then we want to find the value of f of 2, that is a current. We can draw a table for iterations and the value of the current variable. We can see for n minus 1 iterations, we calculate the nth Fibonacci in the current variable. The time complexity is O of n, and the space complexity is O of 1. We can also use golden ratio to compute Fibonacci. In this case, we can just plug in the formula, the values, and this will be dependent on the time complexity of the square root function we'll be using as part of the language. Sign up for your free coaching call by going to codinginterview.coach.